Let's look at November 2021. November 2021, question 5. So we are looking at trigonometry question here. So question 5.1, 5.1, sine 140 degrees times sine 360 degrees minus x all over cos 50 degrees times tan negative x. Right here, I want us to just make sure that everything is written in the form something minus something here. Like if it's 140, we can write it as 90 plus or 180 minus. So we write it using the corner angles. So the corner angles are the 0, the 90, the 180, the 270, and then the 360. So we have to rewrite this. So we need to check where the angle is, which quadrant. So it's in this quadrant, so we can write it as 90 plus something or 180 minus something. So but we can simply look at the other angles that we have. Now this 50 is catching our attention, so we can actually write it as 90 plus 50. So this is 90 plus 50. Right, you could have also have written it as 180 minus 40, but then you're going to have to deal with the 40 and the 50. So this one, sine 360 minus x, it's fine, it's in the way we want it to be. Now tan x, it's the same as 0 minus 270. Rather, it's in the fourth quadrant, it's 0 minus x, so that's why it's just negative x. We can just rewrite it as 0 minus x. Now, I want us to ask ourselves just 3 little questions so that we can reduce this, because this is a reduction formula. Now, question 1, we need to know the quadrant in which the angle is. And then after that, we need to check whether the sign of the ratio is positive or negative. And then we need to also check the last question. We need to check whether we're going to change the ratio or not. Now we change it if it's one of these angles here. If it's a 90 or a 270, we need to change to its cofunction, so the sign must change to cos. So at all costs, we need to avoid tangent being a 90 or 270. Otherwise, we will have to change it to sine over cos. All right, now here we start. So the 90 plus, it's in the second quadrant, and the sign of sine in quadrant number 2, it's positive. So this is going to be positive. And then changing or not, in this case we have to change because it's 90, so the sign will change to cos, and we put the angle that is there. So this is 50. Right, and this one, 360 minus is in quadrant number 4. Is it positive or negative? It's negative in that quadrant. We don't change it because it's not 90 or 270, so it keeps we keep it as it is, so it's sine, and we put that angle there. Right, all over cos 50 it's already been reduced, we can rewrite it as it is. Now 0 minus is in quadrant number 4, and tangent in quadrant number 4 is negative, and then we don't change it, so it will just remain the tangent of x. Right, so this the cos 50 will get rid of the cos 50, the negative will get rid of the negative, and then we are left with the sine x divided by the tangent x, which we can rewrite it as sine x over cos x. Now we can change the division and make it a multiplication. So in that case, we will swap this. So we will have the cos first. So the cos will go up and the sine will go down. So we will have the cos x over the sine x. Right, now the sine x will cancel out the sine x, it will divide it out, and then we are left with cos x, which is actually our answer. So that was the first 6 marks. Right. 5.2. Prove the identity minus 2 sine squared x plus cos x plus 1 all over 1 minus cos into 540 minus x. So we need to prove that this equals to 2 cos x minus 1. Right, we rewrite it here. So obviously we will deal with the left hand side. Right, now we are looking at this. This is a sine, this is a cos. It looks like a trinomial, but the problem is the sine and the cos here. We have to change one so that they look alike. They either both sine only or cos only. So, but the one that can be changed is the sine squared, because it's already squared. We can use the identity sine squared x plus cos squared x is 1. Therefore, we will have negative 2 into sine squared x. We can write it as 1 minus cos squared x, and then this is plus cos x plus 1 all over 1 minus any angle that is more than 360. We subtract 360 up until it is less than 360. Now this is 540. If we take 540 and subtract 360, we will be left with 180. So this is 180 minus x. Right, removing the brackets here, we will have a negative 2, then the plus 2 cos squared x, then we have the plus cos x plus 1. Now this one, we ask those 3 questions, so it's 1 minus, now 180 minus is quadrant number 2, and cos in quadrant number 2 is negative, so it's negative. Then we have the cos of that angle, which is x. Right, so now we want to put this upper part in standard form. So we are going to have 2 cos squared x plus the cos of x minus 2 plus 1 is minus 1 all over 1, a negative and a negative will be plus cos of x. Now the upper part is a trinomial, so we can factorize this trinomial properly. So we will have 2 cos x and cos x, so we have a 1 and 1, so then negative and a positive, so the positive will come here and negative there, so all over 1 plus cos of x. Right, now the 1 plus cos x will cancel out the 1 and the cos x plus 1, so it's the same thing. 2 plus 3 is the same as 3 plus 2, so we are left with 2 cos x minus 1, which is what we wanted to prove, that this is 2 cos squared x minus 1. So that concludes our proof. So we have the left hand side equals to the right hand side. Right, 5.3, it is given that sine of 36 equals to the square root of 1 minus p squared. Sine 36 equals to the square root of 1 minus p squared. Normally we have to draw a triangle on a Cartesian plane and in the first quadrant, and now we have our 36 here as an angle. We can even have, because the sum of angles in a triangle is 180, so we can even have this as 54. Right, Sine, we know it's opposite over the hypotenuse side, so if it's just this, so it's like it's over 1. So this opposite of 36, it's our square root of 1 minus p squared, and the hypotenuse is 1, and we actually use the Pythagoras theorem to get the x values here. So we will simply say the x squared, we know that it is the r squared minus the y squared. It is r squared is 1 minus y squared is the square root of 1 minus p squared. So this will give us, this is all squared, so 1 minus the square removes the square root, so we have 1 minus p squared. So this is giving us 1 minus 1 plus p squared. So x squared is actually p squared, meaning x will be p. So now we have the side to be p, so we can now answer any question. So going back to our question, 5.3.1, 5.3.1, 5.3.1, we want tangent of 36. So tangent of 36, we can go to our diagram that we have completed. So tangent of 36, we know that the tangent is opposite over adjacent, so we will simply write this as the square root of 1 minus p squared divided by the adjacent, which is p, right? So 5.3.2, 5.3.2, 5.3.2, we need cos 108, cos of 108, cos 108, the cos of 108, we can write it in many ways, but one of the ways that we can do it is to change the 108 into a double angle of 54. We can write it as 2 times 54. Right, so this is a double angle. Now, double angle of cos, so there are many ways of writing the double angle of cos. We know that one of them, the first one is cos squared x minus sine squared x. The second one is 2 cos squared x minus 1. The third one is 1 minus 2 sine squared x. Right, so we can take any of these three. Right, so I will prefer 1 minus 2 sine squared x, so the x is 54. Right, so this is 1 minus 2, and then sine of 54, and 54 is this angle here. Sine, we know that it's opposite over the hypotenuse, so opposite to 54 is p, hypotenuse is 1, so it's just p. So we can just write the p, but it is squared. Right, question 6. Given cos alpha minus beta equals to cos alpha cos beta plus sine alpha sine beta. So this is given. Now 6.1.1, use the given identity to derive a formula for cos alpha plus beta. So we are going to use the formula for cos alpha minus beta to derive a formula for cos alpha plus beta. Right, the first thing that we need to do here is to write the two to look alike. So we must have the first angle, a minus, and the second angle. So we are going to write this as cos alpha. We have a negative here, so we will put a negative. So but we should not change the question. So it means we will write this as a negative beta, so that we don't change the question, it goes back to minus. But now we have written it to look exactly like this. We have the first angle, we have a minus in between, and then we have a second angle. So we are going to substitute this as they are on the formula that is been given. So this equals to cos of the first angle So we will write cos of alpha, then cos of the second angle, our second angle is negative beta, right? And then plus sine of the first angle, sine alpha, and then sine of the second angle, which is negative beta. Right, so we know that this is our cos alpha plus beta. So this is, now as we ask the three questions, a negative beta is the same as actually 0 minus beta. If we have to rewrite this one, this is 0 minus beta. So 0 minus beta, it's actually in the first quadrant. No, it's in the fourth quadrant. So this one doesn't change, it's just cos alpha. Now, fourth quadrant, a cos is positive in the fourth quadrant and it doesn't change, so it will just be a cos of beta, right? Plus sine of alpha. Now 0 minus, we said is the fourth quadrant, but sine in quadrant number 4, it's negative, so it's going to be negative sine of beta. Right, rewriting this, we will have a cos alpha, cos beta, a negative and a positive, so that would be minus sine alpha, sine beta. So that is 6.1.1. Right, here we can rewrite this 10 as 6x, this 10x as 6x plus 4x, so that we are guided by this 6x and 4x here because it's a 10x, and then we can now expand there. So we are going to have 2 cos 6x cos 4x minus, now we need to be careful here because we are subtracting more than one term, so we need to put it in bracket. So we have, now we have just proved that a cos alpha plus beta is the same as cos, so it's going to be 6x cos 4x, and then if it's plus, it's going to be minus sine 6x sine 4x. So this is then plus 2 sine squared x. Now removing this bracket, we will have 2 cos 6x cos 4x. Now this is going to be a minus cos 6x cos 4x, and this is going to be a plus, negative and a negative, it's positive, and sine 6x sine 4x, then plus 2 sine squared x. Right, the first two, these are like terms. 2 minus 1 is just 1, so we will just have cos 6x cos 4x for the first two, and then plus sine 6x sine 4x, then plus 2 sine squared x. Right, now if we look at this, cos 6x for cos 4x sine 6x sine 4x, so this is a compound angle of cos, so it's going to be cos the first angle, which is 6x here. If it's plus here, it's going to be minus the second angle, which is 4x. So this is plus 2 sine squared x. Now 6x minus 4x is of course 2x plus 2 sine squared x. Now 2x, we said we can write it in three ways. We can write it as cos squared x minus sine squared x, or we can write it as 1 minus 2 sine squared x, or we can write it as 2 cos squared x minus 1. So let's just take 1 minus 2 sine squared x, then the plus 2 sine squared x. So this subtract this and we are left with 1. So any of the three methods could have led us to 1. Right. 6.2. Determine the general solution of tan x equals to 2 sine 2x, where cos x is less than 1, is less than 0 rather. So meaning cos x is negative. Okay, so we can write tangent x as sine x over cos x. So this equals to 2 sine 2x is, it's 2 sine x cos x. So it's a double angle of cos, of sine rather. Alright, so we can multiply both sides by cos x. So this, the left hand side will be left with sine x, and the right hand side, 2 times 2 is 4 sine x, and the cos times the cos is cos squared x. Alright, so we can take this to the other side. So we have sine x minus 4 sine x cos squared x. So this equals to 0. Taking out the common factor here, we will have sine x, and we are left with 1 minus the 4 cos squared x equals to 0. Now giving us sine x to be 0, or put it this instead at 4, cos squared x will be positive 1 over 4. Alright, so now the answers for this one, we look at it, it's positive, so sine is positive in quadrant number 1 and number 2. So in number 1, we'll write the angle as it is, so it means x will just be the angle 0 plus the revolution of sine is 360k, giving us just 360k. Or in number 2, in quadrant number 2, x, we will say it's 180 minus the angle is 0, then plus 360k, meaning the answer is 180 plus 360k. For this side, remember square is plus or minus, but in the question they said cos is negative. So if we find the square root there, we will write the negative 1 over 2. Remember they said cos is less than 0, so that is why we are taking the negative. Right, so our reference angle here will be, if we look at shift cos 1 over 2, we will get a 60 degrees. Right, it's negative, so it's cos is negative in quadrant number 2 and number 3. So meaning the solution for this side will be x is, in number 2 will be 180 minus our reference angle, which is 60, then plus 360k, giving us 120 plus 360k. Or in number 3, x will be 180 plus 60. So we add the 360k, and we will get 180 plus 60 is 240 plus 360k. Now we should not forget to indicate what this k is. So k is an element of integers. Thank you very much. Please don't forget to like, share, and subscribe.